So this is a diagram of our finished filter. We started with the 1" by 6" housing in order to maximize the time that the dye has to travel through the media that we chose, which was the activated carbon. In order to hold up the activated carbon in the housing, we used the fine filter paper, which fit just right around the 1" diameter of the housing, and we put a rubber band around it so it wouldn't fall off.
So one of the big complications that we came across in our design was we were trying to figure out how our device was going to stand up on its own. So when we were buying our materials, we bought the plastic and paper cup as just excess stuff that we figured we could mess around with and hopefully come up with a solution. And actually, as it turned out, the diameter of the plastic cup was just small enough that it was able to fit within the rim of the paper cup and almost form a suction seal. And when we took this down, it was sturdy enough that it wouldn't wobble and would support our structure. So what we did is, we had the plastic cup on the bottom, paper cup on top, and we poked a hole with the funnel through the paper cup. And this funnel, wrapped in cheesecloth, was able to support our housing from wobbling back and forth.
So this is our cost analysis for our completed filter. Our total cost was $142 with a total mass of 159.69 grams. As you can see, our two most expensive products were the 1" pipe, which was 6 inches in length, and the granular activated carbon, which was $35, along with the $70 for the pipe. The reason we went much more pricier on these two products was we were very focused on the quality of the filter, while as you can see on the rest, we were much more cost effective because it didn't play as much of a role in the quality of what was being filtered.
4 iterations of our filter. We started with the fine sand, glass beads, aluminum oxide, and charcoal with the cheesecloth in between all of them. We ordered them in this way because the mesh size, we went from low to high. We put the fine sand underneath the glass beads, even though that the mesh size was lower in this one than the glass beads, because we wanted the fine sand to take out the charcoal, because we noticed that the charcoal kind of made the water black. So we wanted to do that. We had the coarse filter paper on the bottom just to hold it up. And then after that, we realized that the glass bead and aluminum oxide really didn't do anything. So we came here, we took those out, and we put the cheesecloth in between them because we realized that the cheesecloth actually did take out some of the dye. So we kept the fine sand to take out the blackness of the charcoal, and we kept the coarse filter paper on the bottom. We realized that the more tests we ran, the less black it was. So we figured that the charcoal was kind of dirty. So we completely did away with the fine sand in front.
And now we're going to talk about the design approach of our project. And we represented it with this flowchart. So initially, we started optimizing cost because we saw in the rubric that they only gave us a finite amount of dollars to spend on it. So we tried to optimize cost, and initially our cost was very low. However, when we got the supplies, we tried to optimize flow rate, and initially our flow rate was very good. It was a solid stream coming out. And when we optimized flow rate and cost, that ended up well. However, when we started measuring the actual dye removal, that was not as good. So to optimize dye removal and flow rate, we had to kind of put cost to the side and not optimize that as well as these two. So from there, we optimized flow rate and dye removal together at the end, and that's where we ended up at our last design.
Alright, now we're going to talk about the performance of our filter. So we had a flow rate of about 0.59 milliliters per second as we flowed 10 milliliters of water in 17 seconds, and we had a dye removal of about 85%. That was given to us from the spectrophotometer that was in the room. We also calculated the absorbance of our filtered water from our Arduino spectrophotometer, and this was a value of about 0.129 absorbance. So right here on the graph, 0.129 is about right here. And if you were to go down, that gives us a concentration of about 0.2, and this lines up very well with our dye removal rate of being about 80 to 85%.